Want to really truly understand color? A great place to start is HSB. Right at the outset, I want you to know two things. First of all, this is a deep exploration of HSB. I really want you to understand what's going on. So this is a longish video, but I'm including time codes so you can skip around as much as you want. Come back to various topics as well. Another thing to understand is that HSB is such a great way to define colors, not because it's a very precise color model. It's not. It's not calibrated. It's not characterized. It's not so much as profiled. It's a very loosey-goosey color model, which is what's so great about it. It's easy to understand. And so once you come to terms with its ingredients right here, hue, saturation, and brightness, which you will most assuredly by the end of this video, you can describe any color you like. And it's so integral to understanding Photoshop that it's featured right up here, right up front, that is, inside the color picker dialog box. Notice that they are the lead values. And to see what that looks like, I'll click on the foreground color at the bottom of the toolbox. There are my various values starting with HSB. Notice here inside this field, by default, you're going to see a field that goes from dark at the bottom to bright at the top and gray on the left-hand side to very saturated over on the right-hand side. Then you'll see these various core colors or hues represented on this vertical bar. But that can get messed up. Notice if I switch to B. For example, if I select this circular radio button in front of the B value, then brightness is now represented inside this vertical bar, and we're seeing hue saturation variations inside the square field. Things get even more just flat out bizarre if you select something like G for green. Then, believe it or not, I'm seeing variations in green in this vertical bar. It doesn't look like it, but watch the G value. It's the only one that changes of the RGB values, that is to say. Notice red and green, red and blue, that is, don't. Whereas if I drag in the field, the red and blue values change and the green value remains stationary. It's a little, again, it's predictable kind of if you switch to a shade of green in the bottom left corner right there, then you can see green inside of that vertical bar. But still, does the blue and the red, do those make sense as variations inside the field? In which case, if this happens to you, you don't need to cancel out or quit the software. Just select the radio button in front of H, and that will lock down the H value. It'll associate the hue value, that is, with the vertical bar. I'll go ahead and set it to 0 degrees. And now if I drag inside the field, notice the saturation and brightness values vary, but the hue value does not. The other values that vary are everything else. Notice red, green, and blue, the lab values, the CMYK values, they all vary to keep up with whatever color you are selecting inside this field. And so notice it's represented by this new swatch right here, as well as these various values that vary, as I'm saying, from color model to color model. Now, a brief note about the hex value. A lot of people know this. A lot of you know this, is what I mean. It's great for copying a color and pasting it into a different piece of software, because hex values are universally supported these days, especially by web apps. Very, very convenient. I just want you to understand how it works. It's 6 digits, as you can see. They're hexadecimal digits, meaning they go from 0 to F. So 16 variations per digit. Not the way most of us think of things, but that's okay. I just want you to very briefly know that the first 2 digits represent red, the red value. The second 2 represent the green value. And because our green and blue values are the same, we have the second and third group of 2 digits being the same as well. And you don't need to know specifically any more than that, because Photoshop's going to go ahead and update that hexadecimal value on the fly. All you need to do is select the color you want, then just select that value, copy it, Control or Command C, and then paste it into a different application. All right, I'm going to cancel out here. Now, I want to keep this a high-level discussion, so you understand all about HSB without getting mired down too much, with the exception of this one slide. This is the technical slide in this slideshow, by the way, and that's because HSB is very special in that it is not as locked down and absolutely rigid as RGB, CMYK, and Lab actually need to be. And so notice if I go up to the image menu, choose mode, that we have RGB color, CMYK color, and lab color. So these are actual color modes. The other ones are. They change the composition. If you switch to one of these modes right here, if you select one, then you're going to actually change the composition of the image. You'll change the content specifically of the channels panel. You may have to flatten the image. A lot of other stuff is going to go on. That's not true with HSB. HSB just floats along. Very carefree, but very loosey-goosey as well. So RGB, let's just understand what we're working with here. Red, green, and blue are the primary colors of light. They're used to capture digital images. So they're used by cameras. They're used by, your smartphone and so forth, scanners as well. And then display the image, whether it's on a computer monitor or your smartphone, once again, or your iPad. It's true of old devices out there. So, cathode ray tubes from the 1950s, as well as new stuff. Like the Apple Vision Pro is an RGB device. CMYK is exclusively pre-press, that is commercial printing, cyan, magenta, yellow, and the key color black. By the way, what CMYK stands for, those are inks involved in pre-press. This is exclusively for commercial printing. Those of you who print your images at your home or office, you have a deluxe, absolutely sweet inkjet device, stick with RGB. Even though your inkjet device features cyan, magenta, yellow, and 7 different shades of black. That's okay. You don't want to hardwire a CMYK image, because if you do that, you'll reduce the color gamut and you'll get fewer colors out of your printer. It's not the thing you want to do. In fact, unless you're really familiar with CMYK or you are actually a pre-press professional, then you can steer clear of CMYK entirely. You don't need to worry about it too much. Lab, by the way, is device independent, meaning it's neither screen nor print. It is profile, D65. It is also a great way to correct colors. We saw that a couple of months ago, maybe 3 months now. We'll see it again in the future. It's not so great for describing colors, however, because it's difficult to predict, and it doesn't make any sense, really. Not like, correct me if you're just like an absolute lab robot and you know how to dial in any color there is. I don't know how to dial in red using lab, whereas HSB is 0, 100, 100. So it's very easy. And that's because it's not a color mode. Rather, it's a casual way to describe colors, usually in the context of an RGB image, usually. You can use HSB in any color mode. So it could be CMYK, it could be lab as well. All right, now let's start looking at the individual ingredients, starting with hue. And I'll start with a definition, a clinical one, if you will. It's the perceived or pure color, independent of such attributes as intensity, tint, which was brighter, or shade, which is darker, by the way, technically. But all I'm saying is it's measured in degrees around a circle, starting and ending with red at 0 degrees. What could I possibly be talking about? Well, here inside the color panel, one of the things you can do is click on the hamburger right there and switch to color wheel. And that will give you the HSB value, so you have numerical control. And we're going to see the hue wheel around the outside, so 360 degree circle, by the way. And then where this triangle is concerned, I'm not going to dwell on it, but very briefly, saturation is represented horizontally and brightness is vertical. So enough of that. But I just want you to see, notice the hue value right there. It starts at 0 degrees, which is red. Over here on the right-hand side, you can see that, right? This is the way the circle is configured inside Adobe apps. It doesn't have to be oriented this way. It could be any old circle. They could be, at different angles and so forth. And the hue values increase as you drag this thing in a counterclockwise direction. Again, that's an Adobe conceit, but because Adobe is a very powerful, industry standard, this has become an industry standard as well. And so just know, as you move it in a counterclockwise direction, you're going to increase this hue value, and you're going to end up with different hues, such as green or cyan or blue or what have you. Let me show you right here in the middle of the window. Here is the hue value, by the way, and I want you to really appreciate this guy, the way I've set it up. I'll go ahead and switch to the eyedropper tool, which you can get handily by pressing the I key here inside Photoshop. And I want you to watch. If I click over here at this location, I just reset the hue value to 0 degrees. I nailed it. But if I keep dragging a little bit upward, notice that I'm increasing the hue value as I move in a counterclockwise direction through orange and yellow. You may see the brightness value drift a little bit, but mostly the action is happening where the hue value is concerned. Wait, do you like this slideshow? Do you think it might be helpful to review it in Photoshop whenever you like? Then it's yours, along with this poster-sized version of the color wheel. Just join my Patreon, which is patreon.com/geeknow. And now, back to HSB. And so anyway, notice that as I drag in this counterclockwise fashion, I keep increasing the hue value and I drift into different core color territory. Now, because HSB is so very generalized, it includes everything else as well in its own special way. So here is red, green, and blue, the primary colors of light, represented as an absolutely equilateral triangle. We'll see with HSB that the beauty of it is everything's geometric. And so at 0 degrees, so a circle, right, is 360 degrees all the way around. And once you get to 360, let me show you that. I'll go ahead and drag this guy up. This is very important. Watch that hue value. See how it's 359 right now in the top right corner of the screen? As soon as I move it up just one increment, it is now 0 degrees. So 360 resets to 0. They are one and the same. And so you divide a 360 degree circle into three parts, you get 120. So just 360 divided by 3. So 0 is red, 360 is 120 is this very bright green, kind of neon green. 240, 120 plus 120 is this dark, rich blue. And then we get back to red because it resets at 0 degrees once again. Now, if you want CMYK, you're not going to get, cyan, magenta, and yellow. We're not going to get K, we're not going to get the key color black because that's specifically a print thing, even though we do have blackness in the background of this slide. But cyan, magenta, and yellow is essentially a kind of opposite of RGB. And as a result, you take this triangle and you rotate it 180 degrees to get this one right here. So red gets rotated 180 degrees, it becomes cyan. There it is. Add 120, pardon me, and you get 300. So, you know, if you were to whip out a calculator, you figure that out. But I'm just telling you, which is magenta. Add another 120, 60 degrees, you reset to 0. And then another 60 degrees takes you to yellow. And then 120 more takes you back to cyan. So we've got cyan, magenta, and yellow. Now, that doesn't exactly match the inks if you were to go to an actual commercial print house or take a look at the inks that are produced by your local inkjet printer even, you would see that they're a little more rich and kind of darker as well. Watch these circles, by the way, that change. That cyan circle, you see it change from a bright cyan to a darker one right there. I think it's more obvious if I change the color of the text as well. So these are the hue values. This is 60 degree yellow, 180 degree cyan, 300 degree magenta. So it's very bright colors, whereas the inks look like this. So notice that cyan and magenta specifically settled down, and cyan is more blue. So it's like farther along the hue wheel. Magenta is farther along the hue wheel in a counterclockwise direction. So it's pinker. Yellow is pretty much the same. So this is a hue 60 degree yellow, and this is an ink yellow. It's a little warmer. You probably couldn't see any difference right now, but they work together as well. So if I were to superimpose RGB on top, we would see that every one of these primaries is 60 degrees different in this perfect, generalized, loosey-goosey world of HSB once again. So add 60 degrees to 0 and you get yellow. And then another 60 degrees gets you green, and then cyan and blue, and so forth. And we end up with these equilateral triangles that are forming a perfect 6-pointed star. Now, that star might be a little confusing, so I'll hide it so we can see just the primary colors by themselves. Now, I want to stress, these are just the primaries. Lots of other colors are here. You can see them all. That's what's great about the Hue Wheel. They're all right here. So I could click right at this point to lift a shade of orange and see that it has a hue value of 32 degrees. So all kinds of values are available in between. Now, I really want you to understand that these colors are all complements of each other. They're not complementing each other. Red isn't saying, gosh, cyan, you look great today. They are color complements, C-O-M-P-L-E, and so forth. And as a result, they're essentially opposite colors of each other, red and cyan, yellow and blue, green and magenta. And if you were to mix them together, you're going to get a neutral color, gray, some shade of gray or white or black or what have you. And so as a result, they can work great together. I'm not going to go into that kind of color theory all that much, but I do want you to see that here's the color theory I will explain. The reason that these colors work this way is that in a perfect world, sunlight, white light, light from a white light source includes red, green, and blue, all mixed together to form white. So at full intensities. The whole purpose of the cyan, magenta, and yellow inks is to absorb that light, absorb specific frequencies. So cyan is designed to absorb red. That doesn't make any sense. Yeah, it does, because it reflects back green and blue. So you're not seeing any red anymore, but we are seeing a shade of greenish blue, which is cyan. Magenta is absorbing all the bright green light, and it's reflecting back this dark blue and this red right here, and so it looks kind of purplish, right? Whereas yellow's the one that throws people, I think. It's absorbing this. It's this bright yellow absorbing this dark blue, and as a result, it's reflecting back red and green, and red and green together at full intensity gives you yellow, which is why this is why I don't bother to actually mix colors, to define colors using RGB, even though that's one of the simpler ways to work. HSB is just so much more convenient. You can see them all there on that Hue Wheel. I want to stress once again. And so if ever you want to find a color complement, just add 180 degrees. Let me show you what I'm talking about. I'll go ahead and switch to this guy right here, just by way of a demo file. And notice that I've got this hue saturation adjustment layer right here set to colorize. And so we're just seeing this hue 220 degrees. And that's true. By the way, it will vary a little, but notice if I drag with the eyedropper, watch the hue value. It's 219 degrees right now. The saturation and brightness are going to flop all over the place, but the hue value is going to remain more or less fixed around the 220 area. Now it's 222. So we are seeing it vary a little bit despite the colorization, despite the absolute application of 220. If you want to see what 220 looks like in that file, once again, you can just drag inside of it like so. And so notice if I click inside the circle, the hue value is 240 degrees exactly. But if I want 220, I would drag to this location right here. You can see the hue value in the top right corner of the screen. And so what if I want this color that's way over here on the other side? And I want it to be an exact color complement. Then what I would do is add or subtract 180 degrees. Now, I can't really add 180 degrees to 220. Notice if I try to enter plus 180, Photoshop doesn't do that math. It will do it, but it gets grumpy, and it just says that's more than 360, so I'm not going to accept it. Now, what Photoshop should do is figure out what the equivalent is. It should do the real math for me, but it doesn't. It just gets angry. And so, or grumpy. Anyway, 360 is what it comes up with, because that's as good as it can do. But that's the same as 0. If I change this hue value to 0, it's still red. Bright, vivid, incredibly highly saturated red. It was 220 though. Let's set it back. And instead of adding, subtract. If the value is more than 180 in the first place, try subtracting 180. And notice as soon as I press the enter key, after entering that math, I get 40 degrees for this complementary color, and it complements like crazy. It shows off this color combination beautifully. And so once again, if I were to drag around inside this guy to 40 degrees, you can see that it is indeed a sort of yellowish shade of orange. So I just want to stress each one of these colors we're seeing is color complement, 180 degrees apart. So these lines are demonstrating that 180 degree difference. All right, now let's turn our attention to saturation. It was starting with the definition, of course, the intensity of a hue measured as a percent. So I want to stress, hue is measured as degrees on a circle. Both saturation and brightness are percentages. So 100% is going to be the most saturated, and 0% is going to be the least. I'll explain that in a moment. Hue plus saturation equals color. So there's yet another thing in HSB, and that's the color. That's basically the color minus brightness. So hue saturation, and that is a technical term, by the way, something you should bear in mind. Assuming maximum brightness, which would be, of course, 100%. Oh, let's take it up to 100% right there. A saturation value of 0 is white. That's something to bear in mind. Look, you can see the slider colorized for your enjoyment right there. So take it down to 0 degrees, it's white. Whereas saturation of 100% is the full-on version of the color. That's why I wanted you to understand that term. So in this case, the color is orange. This is a fully saturated version of it. This is an unsaturated version, which is white, assuming a brightness value of 100%. So here we have hue. And what we're going to do is add saturation. So there's saturation from 0% in the center to 100% all the way around the perimeter. And when we blend them together in order to get color, we get, notice here, just for, LARFs, I'm showing 50% saturation right there in the middle, going to 0% for white. We get what's known as I just want to show it to you for a second by itself, but then we get the color wheel. So I just want you to see how it's white in the center going from all different directions at 100% brightness. But it is called the color wheel, by the way. And so now let's see some varieties not on the wheel, because it's easy just to, confuse colors with each other when you're seeing them mixed right next to each other. So what I'm doing is I'm showing you not only the primaries of red and yellow and green, so red, green, blue, as well as cyan, magenta, and yellow. But I'm showing a couple of additional colors, perceptual colors, if you will, in between, like that are really prominent colors that you would miss if they weren't there, like orange, which is all of the skin tones, by the way, and violet, which is located between blue and magenta. So I'm just showing those as well. Here's their hue values: 0 degrees for red, 30 degrees for orange, 60 degrees for yellow, all the way to 270, by the way, for violet. And then here's the saturation value: 0% at the bottom to 100% at the top. Because brightness is set to 100%, it's white at the bottom to full-on color at the top. Whereas if I take that brightness value down, I just want you to see how brightness works with all this other stuff. We're still varying things. The hue and the saturation values are the same. So the degree value is the same. The saturation values still go from 0 to 100. But now we're starting with very dark colors at the top, 50% bright, down to gray, 50% gray at the bottom. All right, so now let's go back to the color wheel, just so we can see how the color wheel changes as we reduce the brightness value. Now, it changes in a way you might not expect. At first, it's just like you expect. Here it is, brightness 100%. Here it is 70%. So now we're going to a shade. I'll switch back to the eyedropper. If I click in the center there, notice the brightness value in the top right corner of the screen is now declined to 70%. Instead of 75%. That's I monkeyed with this little one, but a little bit, that is. But in other words, we're getting down to a saturation value of 0, almost right there at the center. So it's gray. It's a light gray. Whereas with the brightness value 50%, it's a mid gray. I think I actually set this to 50%. Yeah, I did. Notice that the brightness value is 50% right there. And I'm trying to make this a rich experience for you, don't you know? And then this is 25%. So we're getting a dark gray in the center, dark colors around the perimeter as well. There it is at 10%. I want to get really super dark. Notice you may see this, you may not in the video. You may see banding happen, and that's because we actually have fewer colors. More on that in just a moment. And here's a brightness of 0%. A brightness of 0% gets you black. Every color becomes black. Every combination of hue and saturation becomes black. There is nothing but black. That's why we're seeing a black circle against the black background. If I brighten the background a little bit, there's our black circle, just so you can see it. Now, here's the trick. That wasn't a good representation at all. Here is a brightness of 100%. That is a very big color wheel. And now if I darken the brightness value, if I reduce the brightness value, that reduces the size of the wheel, of that wheel, in a linear fashion. So it now has a diameter that's 75% of what it was before. So I've taken the diameter down to 75%. You don't have to worry about pi or the circumference or the volume or anything like that. Just diameter, radius, that's it. And then they're not the same. Radius is half the diameter, but you know what I'm saying. Take it down to 50%. It's now half the diameter as it was at the beginning. So this is big, this is half. And then it goes down to 25%, and then I'll just take it down to 10%. There it is. It's really dinky now. We have very few colors left to work with. So we have the same theoretical range. That is, we can enter the same values as we could before. But now if I press the I key to switch to the eyedropper, notice tiny little, watch the hue and saturation values, or watch the HSB values in general up there in the top right corner of the screen. Notice how fast they change. And that's because there's very few colors. It's a tiny gamut, if you will, that's available to us. So we can enter any values we want. We're just not going to get that many colors out of it. So the quantity goes down. And then finally, at a brightness value of 0%, it changes to, there's no reason to even show it. It's a pixel now. It's just a tiny little dot of black is all we're left with at this point. All right, so that was a little bit of a kind of preview of brightness. Now let's see brightness in the mix. Here's the definition. We got to start with that, right? Brightness is measured as a percent. Well, I already told you that, but it's not a degree. So it's just like saturation. It's a percent. And brightness of 100% plus saturation of 100% is full on color. Remember, color is saturation plus hue. And so we get the Hue Wheel that I showed you at the outset. That is brightness of 100% mixed with saturation of 100%. And I'll just go ahead and take these guys up by dragging this guy to the right-hand point of the triangle right there. That will increase those values to both 100%, both saturation and brightness. And now we are just seeing the Hue Wheel. Right there, we can see it. And then, by the way, brightness of 100% plus saturation of 0%, we already saw that, is white, but that gives us the full color wheel. So white's right there at the center. That is the neutral color. That is red, green, and blue mixed together at full intensity by the sun. Thank you very much. And a white light source, of course. And if you want grays, then you reduce the B value. And notice, by the way, that in reducing the B, we also reduce the size of the circle. The B value, that is. And then B of 100% plus anything, doesn't matter what the other two values are, is black. That's always going to be the case. And look, watch this. I'm going to change my hue value all over the place. That is, I'll start with purple. And now I'll take the brightness value down to 0, and it's black. Black is the outcome. Do you see the saturation? The entire saturation slider is black. And it doesn't matter what I change, because that's a preview of what the color is. Doesn't matter what I change the hue value to. You can see the foreground color swatch is black as well. Doesn't matter. Hue doesn't matter. Saturation doesn't matter. Do you see that? Brightness value 0 is always black. So that's something to know about HSB. White is a saturation of 0%. Black is a brightness value of 0%, which means that it's a cone. This is my favorite thing, I think, about HSB. Just as I was telling you, the hue wheel or the color wheel is a perfect circle. They're both perfect circles. They are. And it just, they just live in this hypothetical, I keep saying loosey-goosey, but I just want to emphasize this casual world. Whereas as soon as we start, so this is, the color wheel is showing all the hue values at the perimeter, saturation value toward the center. So we're reducing the saturation as we go toward the center, which is white. And then we're reducing the brightness values we go down. And so it goes from white down to black, and it is a perfect cone as a result. The circle can be any size you want to make it, any theoretical size, and the cone can be as tall as you want it to be, but it's a perfect cone. It's not sort of sideways or slanted or anything like that. Let's compare it to this CIE 1931 chromaticity chart right here, which I got from Wikipedia. But it's kind of a standard, and it's basically designed to, 1931 as a year, represent the way we see colors. And so basically what we're seeing is just the top of the circle. We're not seeing any luminance variations, where this big blob is concerned right there. If we wanted luminance variations, we'd have to project it into 3D, and that's just too much trouble to even represent that. I just want you to see we're seeing a very simplified version of this chromaticity chart. And then these are all the profiled spaces, a bunch of different profiled spaces inside of it. And so, for example, the Pro Photo RGB space is the biggest of these that I'm showing right here, and it's theoretically bigger than you can theoretically dial in colors you can't see, basically outside the visual range. And what we're doing, this is a complete simplification, by the way. The idea that it's a triangle is completely ridiculous. These are just points that are plotted here, 3 points that are plotted in order to form a triangle. It's really much more amorphous than this. And then remember, we're not seeing luminance, so we're not seeing the third dimension of this. Adobe RGB is represented by the red triangle, so it's bigger. Display P3, or as it's known in Photoshop, Image P3, is this green right here. And then sRGB is this little blue guy. So they're getting increasingly small, these RGB color spaces. And then I'm just showing offset print and CMYK just so you can see that it's smaller still. It has some colors that are outside sRGB, but they're well inside the visual range. And that's that purple guy. But it's so much more complicated. And once we start throwing in other spaces, they would all be different, and they're all approximations, and they don't have luminance, whereas this guy's got everything. It's got all the color values, and it's got luminance represented in a single 3D graph that I've created for you. Again, patreon.com/Deke now. Forgot that part. All right, so let's see the same independent perceptual colors, red through magenta, including orange and violet. Brightness is now varying from 0 to 100% with the saturation fixed at 100%, and these are the hue values down here at the bottom. This time, because we're going from 0% brightness to 100%, we're going from black to full intensity color. If we take that brightness value down, actually, if we take the saturation value down, to 50%, notice we're still varying the brightness from 0 to 100. Same hue values. We're now going from black still, because 0% brightness is absolute black no matter what. Doesn't matter what the saturation or the hue is set to. And then we're going up to these paler colors because we're reducing the saturation values. And then notice they get even more pale if I take the saturation value down to 25%. So very pale versions of each of the hues, colors, because it's a mix of saturation and hue. And then finally, if I take that saturation down to 0, we have gray bars across the entire hue spectrum. So it doesn't matter what the hue value is. We're not able to express it because the saturation is all the way down to 0%. Is this making sense? And so let's reset things to a saturation value of 100% again. I just want to make it clear that there are all kinds of colors in between. These are just a few named colors. There are all kinds of hue values in between, as we're seeing in this continuous, accurate gradient right here. Once again, you could eyedrop it if you want to, and you will see the hue values change up there in the top right corner of the screen. But the thing is, notice that this is not an accurate representation, is it? Because we've got all kinds of color variations up here at the top, and we're starting to lose. We're starting to get banding. I don't know if you can see it in the video once again, but I can see some very obvious banding down here at the bottom. And that's because we're losing the color gamut as we darken things up. We have fewer colors available to us. And that's why, in fact, the way to represent this little 2D thing with saturation cranked up to 100%, brightness varying from 0% at the top down to 0% at the bottom, is like this. So we are taking all the hues ever available to us and shrinking them down into one little tiny black pixel right there, which is why the whole thing, once we project it, once we bring back the saturation values, looks like this big cone. And I just want you to see, because we've been taking a look at the perceptual values, I want you to get a sense here. Notice we're not really seeing all that much variation in the greens. This is really something to bear in mind about working with HSB. is that it's not in any way, shape, or form based on how we see color, how we perceive color. It's just based on how we might dial it in to various computer applications. So a lot of different hue values are going to give you pretty much identical looking shades of green. And so let me show you in particular. There's all kinds of areas where we don't perceive that much difference. So I decided to lay down those colors that I showed you in those vertical graphs right there. We got red, orange in between, yellow. Then we get into huge green territory right here. We get to cyan. So we start invoking a little bit of blue. Then we get to real blue. And down here we've got violet, and then, well, I've thrown violet in between blue and magenta just because it's so obvious. It's such an obvious difference as opposed to this shade of green between strictly speaking green and yellow. Don't you see? And then we go back to red. And I just want to show you one more thing. Those of you who decide to join my Patreon, I'm also going to give you this. And notice that we're seeing it at 16.7%. This is an enormous file, by the way. Depending on the resolution you print it at, it could be 4 feet wide. It's really, really big. This is just the color wheel. It is not showing any variations in brightness. So brightness is cranked up to 100%, which is why we're seeing white in the center. But it is showing you a bunch of different variations in terms of the hue along with degrees. And you can see we get into some questionable naming territory with lime and turquoise, cobalt, and violet and so forth. Crimson even. So you may disagree with my color labels, but these are the colors that are available to you when you're working with HSB inside Photoshop as well as other Adobe applications. What do you think? Comment below. Not to mention like, subscribe, and turn on notifications. And don't forget, for those HSB asset files, complete with all sorts of layers, join me at patreon.com/DeekNow. And then go to Deek.com and sign up for my newsletter. I'm Deek McClellan. This is Deek Now.